Hello, this is Sebastian Lehrich from the CloudScale-Project. In this video, I'm going to show you the first step to come to appropriate demands and service effect specifications. Therefore, we continue modeling the TPCW system from the last Screencast episode. I have it still opened here, as you see in the system diagram, and as you might remember, we had this assembly for the homepage, which gives the starting page of this bookshop. And the starting page has a nice welcome message to the users of the bookshop, which either states hello unknown user, if it's a new user, or welcome back XY. And the creation of this hello message is handled by this assembly hello. If we go to the repository diagram of our model, we see that this hello component has a print hello operation. And the behavior of this operation is specified via the service effect specification. If you double click here, we see that there is a demand for creating the string to welcome the users. And the problem we now investigate is how to come to the characterization of this demand. I made this 0.1 up for us to just give a nice example here, or a very simple example. But I now want to show you how to come to these demands by basically measuring these. So the idea is to base these demands on measurements now. And for these measurements, appropriate probes for taking response times or CPU and hard disk utilization have to be added to the system in operation. So we actually measure the CPU utilization of the system, whether the hard disk may be required, so that would be a different kind of resource demand. And we also measure the response times when making a call to this operation. And for the response times per operation, the code has to be instrumented. So we annotate the code by measuring response times, or by sensors for measuring response times. And for CPU and hard disk utilization, we will add periodic utilization samplers, or we have to measure periodically utilization samples from the system under test. Okay, so we now first looked on this model level here to see what we actually want to get next. And now we have a look at the source code of this TPCW system, and we will instrument it by appropriate sensors. And we will also add periodic samplers for measuring CPU and hard disk utilizations. So as this is my Eclipse where I only have stored the model in, I'm now moving my Java EE Eclipse to this window here now, and we basically see that I have my application here checked out in my Java EE Eclipse. So I only have this one project, which is basically the TPCW application. I could open the Java resources, investigate the servlets, and see that I have here several classes. This code is already prepared, so I now just show you how I configured it, basically. And the first step I did was I put the required library files just into the project. So for that I have to go to web app, metainf, and add the Giga monitoring properties file. to the project. Kika is a monitoring framework which can be configured via this configuration file here. So for instance, I set my hostname to the tpcw system string. I also activated monitoring, which you can see here. If I go down, you see more properties. Basically, they are the default settings with one exception. If I search here for an IP address, you see that I configured an asynchronous JMS writer to be the target of my measurements. And the context behind that is that whenever I take a measurement, I asynchronously write package or send this measurement to a message queue where the server lies at this location here. And what I do is I basically just send this message to the message queue where I have a nice visualization for measurements, and from this visualization I will control everything. Using this visualization and setting up the server for messages is part of another screencast. Here we just concentrate on the instrumentation itself. So the point is you have to have this Kika monitoring properties file to configure Kika. What you also have to have is in the web-in folder. There are some folders necessary for instrumenting the code. The first is under the lib folder. I have a set of libraries that are needed to instrument the code. You see the general Kika framework libraries, for instance. You also see different libraries needed for the asynchronous JMS communication. You see some libraries, for instance these, that are related to getting system data like CPU utilization and hard disks. You see a special library we provide for taking measurements. And that's basically it. So you find all these libraries in our CloudScale repository. You should just simply copy these. Under the classes folder and then meta-inf, there's another important file called aop.xml. And this one configures the instrumentation to have a look at every class where the package starts with tpcw. So I configured it like this. And having all these classes in place and the class paths set appropriately. You can also have a look in the run configuration for that. So in my Tomcat I used to operate the tpcw application. I see that I have the class path includes these libraries, or at least some of these. Most important, the JBoss JMS API and the Cigar 164 library. And in the arguments tab, you see that I most prominently use the Java agent here to activate aspect-oriented instrumentation. And I added my an external Kika monitoring properties file here. You don't have to do that, just stick to the one in the project. Okay, so with these configurations at hand, you can now instrument the code, and that's actually the main message I want to show you here. So let's instrument the sayHello class, which is the class realizing the component hello. So if you look inside this class, I already instrumented it. For that I did two things. I first imported this operation execution monitoring probe from the Kika framework. And secondly, I added this annotation to the method under consideration. This is the print hello method, which is responsible of creating the string hello unknown user in case we have a new customer, or hello XY for existing customers. And that's it, essentially. This annotation takes care of instrumenting this method. So we already got our response time measurements by this code modification here. The messages are sent asynchronously to our message server, which is part of a different screencast. And basically, we are done here. So we can now save and run the whole thing on a server already, because we are done here. One side remark: for CPU and HDD utilization, we provide a set of additional classes that you just have to add to your application. For instance, for a detailed utilization of your CPUs, you just have to include this class into your project. You don't have to alter it. You have to configure one XML file. This is documented here in the header. And this servlet context listener basically registers itself to the Tomcat server and periodically takes samples for CPU utilization. And we provide similar things for hard disk utilization and for main memory and swap usage. Yes, but that's all. You reuse these classes and you're done with instrumenting the code, and you have your application ready to be analyzed or to run measurements with your application. Okay, that's it. In the next screencast, we will learn how to start actually measuring by generating LORD on this instrumented system. And after that, we will finally investigate the actual measurement results. Thanks for watching.